Hi, I am Avinash Kumar. I am research scholar at Aerospace Structures, Department of Aerospace Engineering, IIT Bombay. Today I will be conducting experiment to calculate Poisson's ratio of mild steel. This is a 314727 structural lab, and today we will be calculating Poisson ratio of mild steel. Poisson ratio is the measure of Poisson effect. So, when we apply a load in one direction, there is deformation in other directions as well. So, it measures the ratio of deformation in a direction perpendicular to the loading direction. So, it is given by negative of strain in transverse direction versus strain in axial or loading direction. In this figure, you can see that we have applied load in y direction, and because of that there is a deformation in x direction as well. Now, for your reference, the modulus and shear modulus and bulk modulus are related as follow. E is our modulus. It is related to shear modulus as E equals to 2g into 1 plus nu, and E equals to 3k into 1 minus 2 nu. So, from these two we will get the limits on Poisson ratio. It should be greater than -1 and smaller than 1 by 2. We will be using two relationship. One is bending, deflection and torsion, twist. So, formula for these two are also provided. Our experimental setup consists of a cantilever beam and a bar attached to the cantilever beam at 90 degree. The length of the beam is 750 mm, and we will be applying a load of P value which is varying on one side of the bar, and from that we will be calculating twist via deflection of other section of the bar. So, there is your theta, delta is the deflection due to bending, theta is the twist, A and B values are shown appropriately, and if you refer your manual, you will find out that the Poisson's ratio comes out to be L square upon 3AB minus 1. So, L is given, we have to calculate only A and B. So, we have here is a cantilever beam fixed at this end. The length of this beam is 750 mm, and another bar is attached to this beam at 90 degree angle, as you can see. We will be using different weights to calculate deflection as well as twist of this beam. So, as you would have studied in your bending classes, that when we apply a tip load to a beam, it deflects downward, and when we apply a torque, it also twists. So, using both of these properties simultaneously, we will be calculating the Poisson's ratio of this beam. We have different weights to apply the tip load. We have 50 gram weight, 100 gram weight, 200 gram weight and 500 gram weight, the biggest one. We will be using only 50 gram and 100 gram weight, and this is the mechanism by which we will apply a tip load. Only in this case we will not be applying tip load directly at the free end, it would be offset from the free end by certain distance. So, when we apply a tip load, what will happen is the beam will bend downward, and at the same time it will also twist since the load is applied at this point. So, the torque would be load into distance from the free end. So, it will due to this torque there would be twist in the beam. So, this is a mechanism through which we calculate the deflection, downward deflection and also the twist. So, as you can see, when the circuit is connected, it lights up. We fix one end of this circuit at the beam on the beam body, and another end will fix to the free end of the bar. Yeah. Now, what we will do is we will apply load, and because of the load this beam will go downward and it will also twist. So, the circuit will be disconnected and it will stop blinking, and then So we'll try to find the point that has come up in this section, and we'll drag it. Yeah. So as you can see that since because of the deflection, the circuit was disconnected, but due to the twist, this section came up and that section went down. And when we drag this pointer towards the left end, we'll get to the point which is which was undeflected, which is on the undeflected level due to the twist. So it went downward and this section went upward. So this is the point that that denotes that this is on the same level at the undeflected level. As you can see, there is a scale attached to the bar at the end of the beam. This scale starts from 1 instead of 0, and there is scale in left side of the bar as well as on the right side of the bar. You will see in the manual we have to calculate two values, one is A and another is B. So A is your distance from free end to the point where you apply the load. So suppose when we apply the load at point 13, this is actually 12 centimeter of distance. So you will have to subtract 1. And another unit that you have to calculate is B, which is the point that we get after application of load. After application of load, if the pointer touches at this point, then this complete distance is your B. Again you will have to subtract 1 from this length as well, then you will get B and this will be your A. So we will take one reading, we will apply a load of 200 gram equivalent to 2 Newton, and we have chosen a position, it is showing on the scale as 38. So and actual this length is 37. So this is your A value, which is 37 centimeter, and the circuit is complete, so the light is blinking. Then we will apply the load. And then we will move this pointer. Yeah. So as you can see, the point is 31.5. So in actual this length is 30.5. And this complete distance from point of application of load to this point is your B distance. So 37 plus 30.5, which is 67.5 is your B. These two values you will have to calculate in an experiment to find out Poisson's ratio. So we will be providing you data points as to the load applied, A and B values, and you have to calculate Poisson's ratio of all these data points and their average and standard deviation. That would be your assignment.